Hello, welcome to our technical session on recycling and energy recovery technologies. In this session, there will be one presentation followed by a live Q&A section. My name is Ronald Roach and I'm the current treasurer of the CWWA. I will be moderating this session today. First of all, I want to give a warm thank you to our conference sponsors. We really appreciate the support of Sandpick Contracting Cayman Limited, Deal Metering, Maya, Water Engineering and Pipeline Company Limited, WEPCO, Consolidated Water Company Limited, Dot Enterprises Limited, Florida Aqua Store, and Argo American. Before we get started, I would like to briefly review a few items. You will have the opportunity to submit text questions at any time using the Q&A section on HOFA. Questions will be answered during the live Q&A immediately after the presentation. This is a collaborative session where all in attendance will be able to engage in the discussion during live Q&A. Now, I'm pleased to introduce our speaker, Martin Edelenbo. Martin is a geotechnical engineer with 35 years experience designing and operating waste management systems, both in the public and private sector. Martin is a professional engineer in Ontario and a chartered engineer in the UK. He has been a SWANA qualified manager of landfill operations and waste collection systems, a US EPA qualified supervisor of asbestos abatement, and a hazardous waste responder. He has instructed waste management at universities and regulatory agencies, was a committee member in defining medical waste in Ontario, and assisted in establishing Canadian standards for biogas and landfill gas utilities. Martin's 3 years experience as Assistant Director Solid Waste with the Cayman Islands Department of Environmental Health and 5 years as Solid Waste Manager with the Government of Bermuda gives him unique experience in managing solid waste in a small island locale. Martin, it's now time for your presentation.
Good day, ladies and gentlemen. My name is Martin Aylombos, and I'm the Engineering Coordinator Waste Management with DART Enterprises. It's my pleasure today to present a case study of a public-private partnership between the Cayman Islands government and a DART-led consortium to develop an integrated solid waste management system for the Cayman Islands. Before I start, however, I wish to acknowledge my co-authors on this presentation, Michael Hayworth, Assistant Director, Solid Waste of the Cayman Islands Government, and Andrew Wilson, who is a Technical Director with GHD Consultants. This presentation is an overview of the ongoing process that the partners in this project are engaged in rather than the technical details. The process is still ongoing as financial close is expected in the fourth quarter of this year. If you're not familiar with the Cayman Islands, we are in the Caribbean, south of Cuba, and about 200 miles west of Jamaica. Grand Cayman, the largest and most populated of the 3 islands, is about 95 miles west of the smaller sister islands. Perhaps best known for international finance, Cayman's surrounding reef and clear waters have made the islands renowned for scuba diving. Like most of the islands in the Caribbean, waste disposal operations generally rely on ad hoc land disposal, sometimes in addition to open burning. The photos to the right demonstrate growth of the only disposal location on Grand Cayman that has occurred since Hurricane Ivan hit Grand Cayman in September of 2004. Approaching 100 feet above sea level, the Georgetown dump is by far the highest point of land on a relatively flat island. This project will result in a major shift in waste management operations by reducing the reliance on landfilling by up to 95% through the introduction of a waste reduction center with energy recovery for the residual wastes. The project has recently been branded as Regen. The current waste management strategies on Grand Cayman include setting aside yard waste for mulching and separating scrap metals, including end-of-life vehicles, scrap, and appliances, for future processing and shipment overseas. Infectious and pathological wastes are incinerated through a batch-loaded starved air combustor with a high-temperature secondary combustion chamber. Plastics number 1 and number 2, fiber, glass containers, tin and aluminum cans are collected in dedicated containers at several recycling depots located throughout Grand Cayman near shopping centers and grocery stores. Still in its infancy, the recycling depots currently process about 1% of the waste volume for shipments to overseas recycling firms. Shown in red, the existing landfill is located near the most populated area of Grand Cayman, not far from the center of Georgetown, famous 7 Mile Beach, and clearly visible from cruise ships anchored at the port. When developing a waste management system, one cannot overstate the importance of sound waste volume and composition data. This is particularly true when developing a system that includes an energy recovery facility, since these facilities are designed based both on the waste tonnage and the calorific value of the waste. The government implemented a waste composition study in June 2018. In the absence of potential third-party waste, optimizing the facility size for a 25-year contract period is difficult at best. A fine balance must be struck between short and long-term capacity with capex and affordability. The Cayman Islands government began to plan for a solution to waste management in April 2014 by writing a strategic outline case. This paper sets out broad policy directions and specifically identified the need for a national solid waste management strategy. This strategy had to be environmentally sound, cost-effective, and provide for balance between private sector and public sector services. A significant policy decision was made at that time to avoid searching for a new waste management site. Government employed consultants to assist in developing the national strategy, which included plans to follow the waste hierarchy, 4 R's before disposal, the 4th R being recovery of energy through waste combustion, and an engineered landfill. The inverted triangle represents waste management options from most preferred, waste reduction at the top, to least preferred at the bottom, which is landfilling or incineration without energy recovery. The strategy also considered a need to remediate the existing landfills on each of the 3 islands. The outline business case focused on a comparative analysis of alternative waste management systems that encompass the previously developed strategies. The resulting recommendation is a 25-year horizon, design, build, finance, operate, and maintain contract through a public-private partnership. The outlined business case also recommends a competitive dialogue procurement procedure as the most viable. Government entered the tender process in October 2016 by issuing a pre-qualification document. 3 interested parties qualified and were invited to participate in dialogue with government and to submit outlined solutions in February 2017. After a brief preparation period, bidders were invited to submit final tenders in April 2017. 1 bidder dropped out, and so 2 final tenders were received for government's assessment. A Dartlet consortium of waste management experts, including a local waste collection and recycling company and an experienced international energy from waste provider, was selected the preferred bidder in September 2017. The second bidder was held in reserve should the government and the preferred bidder be unsuccessful in agreeing contractual terms. The path to deliver an integrated solid waste management system is long and not without pitfalls and hurdles. However, with commitment and input from financial, legal, and technical experts on both sides, after a little over 5 years, the parties signed an agreement in March of 2021. The target for reaching financial close is in the 4th quarter of this year. After that milestone, it will take approximately 3 years to complete detailed design, build, and commission the facilities. The solution includes remediation of landfills on each of the 3 islands, transfer of recyclables and residual wastes from Cayman Brac and Little Cayman to Grand Cayman for processing, diversion of up to 95% of waste from landfill disposal, Energy recovery on Grand Cayman will be the mainstay of the waste management facilities, and there will be 8 additional facilities to complement the ERF. Government has decided to manage the sister islands' waste and to deliver the recyclables and residual waste to the Grand Cayman facilities for both affordability and practical reasons. A public education program to support the new waste management strategy is an integral part of the solution. One of the advantages of the design, build, finance, operate, and maintain strategy is that the Cayman Islands government will not pay for the new facilities until they are in operation, as the DECO consortium will finance the capital cost of approximately $240 million US. This capital and the operational cost of the facilities will be paid by the Cayman Islands government through a blended unitary cost per ton of waste managed over the 25-year contract period. At the end of the 25-year period, government will own the land and facilities, which should, in the case of the energy recovery facility, have an additional 15 years of life remaining. Government decided it will continue to operate several of the waste management functions. Those are shown in gray on this slide and include a material recovery facility. Currently, a precursor of this facility is operated by government. Here, the fiber will be sorted and baled, plastics baled after sorting to remove contamination and non-recyclable plastics. Tin aluminum cans are separated and baled, and glass containers ground up into aggregate for local use. The baled materials will be shipped overseas markets to be recycled. Green waste delivered to the site as source-separated materials by the horticultural firms represents about 20% of the waste stream. This material will be turned into mulch or composted for agricultural or horticultural use. A household waste recycling center will include a reuse center and a bi-level container station for various recyclable and waste materials, including special wastes such as e-waste, oils, and batteries. A medical waste incinerator, like the unit currently in operation, but with updated design and control system. The facilities operated by the DECO consortium include a C&D processing facility where materials will be separated and processed for recycling or energy recovery. Oversized materials that will not fit into the feed hoppers for the ERF furnace will be reduced in size at the C&D facility. A scrap metal and ELV processing facility where metals will be processed for overseas shipment. End-of-life vehicles and appliances will be depolluted before processing for shipment. The mainstay of the waste management system, the energy recovery facility, will treat much of the waste that has not been source separated for recycling. The bottom ash facility will process stabilized ash into an inert aggregate material through size reduction and by removing metals into an aggregate material suitable for fill or subbase for road building. Developing beneficial use of this material is an important factor in achieving the waste diversion target from landfill of 95%. The engineered landfill will be constructed to Florida state standards for a municipal waste landfill capable of managing non-hazardous wastes. This site will receive the stabilized air pollution control residue, rendering them non-hazardous, as well as any other non-combustible materials that cannot be recycled. As stated earlier, the Energy Recovery Facility, or the ERF, is the mainstay of the integrated solid waste management system. In this facility, the energy content of waste will be harnessed to produce electricity. The 9.3 megawatts of net electricity that will be sold to the local electricity utility represents about 10% of the power required by Grand Cayman and reduces the requirement of burning diesel fuel to produce this electricity. In this state-of-the-art facility, waste will be burned at high temperatures under strictly controlled conditions to assure complete combustion. The tipping hall is designed with 5 bays to avoid queuing of waste vehicles and assure a rapid turnaround time. The ERF is designed with a single stream from hopper to stack capable of treating about 13 to 14 tons per hour, depending on the calorific value of the waste stream. The waste pit acts as a surge and mixing chamber, the pit can hold approximately 5.5 days of waste deliveries in normal mode of operation. The system is guaranteed to operate a minimum of 8,000 hours per year. Steam turbine boiler technology has been refined over nearly a century into a very robust and reliable system. The electrical generator that converts the kinetic energy into electricity is also highly refined. Converting the calorific content of the waste with a system capacity of 35.5 megawatt thermal into 9.3 megawatts electricity results in an overall net efficiency of about 26%. A manner of utilizing the low-grade waste heat to increase the overall efficiency of the system has yet to be determined. The cooling system is comprised of several deep abstraction wells that provide groundwater for cooling and condensing the steam in the closed-loop boiler system. The water will be injected back into the ground at about 18 degrees Fahrenheit warmer into a different aquifer. Modern waste-to-energy facilities are a far cry from the toxic smoke generators of the past. According to the US EPA, toxic dioxin and furan emissions have declined by 99% from 1990 to 2005. Except for sulfur dioxide, which has a reduction of 88%, and nitrogen oxides at 24%, reductions of 95% or higher in emissions of mercury, cadmium, lead, particulate matter, and hydrogen chloride have resulted from the introduction of maximum achievable control technology regulations. Similar reductions in emissions have been achieved in the EU through best available technology regulations. Due to the efficiency of the air pollution control systems, concerns regarding environmental impacts have shifted more to the management of the air pollution control residue. This material will be mixed with a slurry of cement and pozzolan. When the mixture sets, as in concrete, the contaminants are locked into the crystalline matrix. The mixture can be poured onto molds or simply onto the surface of the residual waste landfill for disposal. The preliminary site layout for the 9 Regen facilities is shown in this figure. The site encompasses approximately 33 acres of land adjacent to the existing Georgetown landfill and is zoned for heavy industrial use. Entry to the new facilities will be from the south along the same route as current waste deliveries. All facilities are sized to accommodate the projected waste volumes to the end of the 25-year contract. However, space has been allocated for a twin ERF if it is required. To manage the risk of flooding, the elevations on site have been designed for the event of a 100-year storm. Sensitive and complex equipment will be installed with additional height above storm flood levels. An environmental impact assessment for the Regen facilities is underway. The terms of reference is currently being finalized and work has commenced on the various disciplines that will be studied. Since the government has decided on the site location and technology as part of policy and strategy, the environmental impact assessment will focus on the potential impacts resulting from the 9 Regen components in relation to the existing baseline conditions. A somewhat separate but important component of the overall integrated plan is remediation of the existing landfills. Government decided to undertake remediation of the 2 small sites on the sister islands, leaving the Georgetown site to be remediated by the DART Consortium. A landfill site environmental review commissioned by government in 2016 identified the environmental impact of the current sites. Remediation Options Report looked at the various available methods to mitigate the issues identified through the environmental review. This report identified that capping, gas management, and environmental monitoring was the best solution to mitigate the previously identified contamination issues. A risk-based assessment confirmed that the solution identified would satisfy the environmental goals. A low permeability cap will reduce stormwater infiltration and thus leachate generation, leachate contamination of surface waters and groundwater. facilitate landfill gas collection, and provide a growing media for native species of plants. Ultimately, after a suitable period of settlement and stabilization, public use of the site as a local amenity is possible. The landfill cap design satisfies the Florida State Administrative Code for landfill closure. Total thickness of 3 feet will be placed in a phased fashion to ultimately cover the entire site. A test installation of about 4,000 square feet will be constructed within the fourth quarter of 2021. In addition to the layers shown here, an erosion control blanket will be installed on the surface in sloped areas. Landfill gas utilization through the energy recovery facility is a win-win situation. Not only will this destroy the methane, a powerful greenhouse gas, but also offsets the fossil fuel combustion required to produce the same amount of electricity at the electric utility. In addition to destroying the methane, capture of landfill gas will prevent any potential emissions of volatile organics and odors from the landfill. This photo, taken from a cruise ship in January of 2020, clearly demonstrates the condition of the site pre-remediation. This is an artist's rendition of the remediated landfill and the energy recovery facility, a stark contrast to the current Grand Cayman skyline view from the cruise ship anchorage area. In conclusion, this project highlights the complexities of realizing a sustainable, integrated, solid waste management system in a small island setting. Thank you for your attention to this presentation, and we are ready to take questions.
Thank you, Martin, for this really informative presentation, and I'm sure it can provide a lot of lessons for our Caribbean countries. At this time, everyone in the session may participate in Q&A. Please keep your mic muted until called upon. If you have questions, you may submit them via text on Hover. We will do our best to answer all your questions. If we run out of time, you can find Martin's contact information on the speakers page on Hover. So, whilst we wait on questions from the panel, Martin, I do have one for you. You mentioned early in the presentation that you looked at a number of different options and then you decided on waste to energy. Can you tell us a little bit more of what that decision was based on? Would it have been cost or availability of land or the suitability of the technology?
Yeah, thank you for that question, Ronald. When it comes right down to it, the government made those decisions. However, if we review their reports on that, they looked at of the various components. They looked at cost. They looked at the environmental sustainability. The major decisions that had to be made, I suppose, is whether to landfill or to go with some form of waste to energy. And I think the major driver there to go to waste to energy was reduction of greenhouse gas emissions.
Right, absolutely. And there's a misconception in the Caribbean that waste to energy can provide your energy needs, and that through the sale of energy, whether it be electricity or heat, that you would recover the cost of the plant. And that's clearly a misconception. You did mention that 10%, that the electricity will supply 10% of Cayman, which is really phenomenal. But do you have any estimates as to what percentage of your overall cost would be recovered through the sale of electricity?
I don't have a firm number. We are still in negotiations with the local electricity provider, and so it's difficult to put a number to that. But I would say that that the value of the energy recovered may approach somewhere between maybe 50 and 80% of the operational cost of the facility, somewhere in that range. which leaves you to still pay for the approximate $150 million for the capital cost of the facility.
Absolutely. And have you worked out what sort of cost per ton that may equate to?
Yeah, and we have an approximate number, but since we are still haven't resolved the financial close of this project, I'm hesitant to tell you what the number might be.
Sure. Right, a question from the audience. How often would the waste from the landfill on the two smaller islands be transferred via ship or plane to the ERF on Grand Cayman?
Yeah, thank you for that. That's a great question. From the operator's perspective, from the DART consortium operator perspective, we would like to see deliveries something like once a month in that range. It might be cheaper for the government to have a longer duration between shipments, depending on how they go about physically doing that shipping. But we don't think it's a good idea to have that waste sitting around for too long before it's processed. So we're hoping that it'll be something around once a month.
And sorry, just clarify: is it going to be shipped across?
Yeah, I think there are at the moment regular, I believe it's regular weekly barge shipments between Grand Cayman and the sister islands. This is how they get all of their foodstuffs, etc. So there is already a regular shipping taking place between the islands, and I imagine, and I'm not sure how government will approach this, whether they'll actually have a separate barge to do this or take advantage of the existing shipping. I'm just not sure how that's going to pan out.
Right. You mentioned that an EIA is now in progress. Are stakeholder consultations part of that EIA, or have you already been involved in stakeholder consultations?
Yeah, that's a great question as well, Ronald. Government, when they started developing their policies, they did have some stakeholder participation at that time. And then now, as we've entered into the environmental impact assessment process, we've had a first session of stakeholder consultation where the public was asked to comment on the terms of reference for the environmental impact assessment. That consultation period ended about 2 months ago, I think. However, once the environmental statement, which is the product of the environmental impact assessment, once the statement is prepared in draft, the public will be engaged again and asked to comment on that.
Right, fabulous. And of course, this is work in progress. What estimate do you have for the plant being ready to start up?
We think we're looking right now at I believe the first quarter of 2025 for the plant to start up, and that would be the main plant, the ERF, as well as the other ancillary functions.
Great. And the final question before we wrap up this session. Thank you for answering the first one. Regarding the hazardous waste, will the ERF treat it locally or ship it overseas to somewhere else in the region or world? Has other countries been selected to receive the hazardous waste?
Are we referring to hazardous waste other than the emission control residue?
I would assume so, like household hazardous waste and other types of hazardous waste that may be generated on island. Yes.
Okay. Currently, the government is collecting those types of wastes and keeping them separate and shipping them to facilities that can manage them properly in the U.S. That process will continue on. Although when the waste to energy facility is up and running, it does have capacity to burn certain liquid wastes, such as waste oils and other types of liquid waste that are immiscible in those oils. So the amount of special waste that need to be shipped off island will be dramatically reduced.
Thank you, Martin. So this session has now come to an end. We hope you enjoyed it. Remember, if you have additional questions for our speakers, you may reach out to them via phone or email. You can find this information at Hoover. Finally, I would like to encourage you all to visit our virtual exhibitors booths to learn more about what they offer and how they can help you. On behalf of CWWA and the Water Authority Cayman, we're so glad you joined us. Thank you for attending.